Good morning. Now we come to day 2 of our electronic course. Yesterday we have learnt about voltage, current, resistance, active and passive components. So now, today, as the day 1 was the basics, today we are going to go with IoT. IoT denotes Internet of Things. IoT is nothing but devices connected parallelly through internet. So now the first major component of the IoT which is required for almost every project is breadboard. Now what is a breadboard? A breadboard is nothing but it's like a junction box. We have used in our houses many times. We plug into only one socket but we get 3 to 4 outputs. Breadboard also does the same. Now I'll show you a practical demo. This is a breadboard. It has pins on its side. These are called shared pins. These are called power rails. So how is this useful to us? So this breadboard acts as sharing. First, we come across, this is the positive line of the breadboard. This is the positive line of the breadboard and this is the negative line of the breadboard. So now, whenever we connect a negative G and D or minus point or to this rail, we can get the negative, which, for example, if we take a battery, we get only one negative point. But if we connect that negative point here, we can get these many points through which we can connect many devices to negative. Same comes here also, positive. So we can, through one battery, we can make multiple devices or connect multiple modules. So this is very useful in organizing things and connecting each other. This is the work of power rails. So we find this power rails in the two opposite sides of the breadboard, left side and right side. It's all interconnected like this, so the power is distributed equally. Okay. Now this is we have discussed that this is power rails. Then what is this? This is shared terminals. Yes. See, these two are not interconnected. This makes a row in between. This cannot share 5 volt. It can share, but it cannot share in a straight line. It is just like a shared terminal. For example, if I want to connect the ESP, it has male headers. So the ESP headers will all align like this. So this also does the same sharing of the pin. For example, it can share multiple pins in here. So if I align it in this row and this row, it leaves one row side. So this is vertically joined fully, but this can only do for one row and in only the horizontal way. Example, this is the power line. It can share terminals, but this is the shade line. Okay, this is only the one thing. It has many ports like this, and it's this one more row of the breadboard. It also has same things like this. We have many under the breadboard like this. So if we connect a thing to here, for example, if I connect a 5 volt to here, the 5 volt is shared among these 3 points. It's simple. Okay, this is the use of a breadboard. Hope you understood it. This is used in many areas like circuits and organizing, sharing power rails. It's very useful. Okay. Now we have learned what is a breadboard. Now we go for the 2 important connections in battery connections. First, series connection. What is the series connection? Series connection is nothing but which increases the voltage, but the current the capacity stays the same. For example, If I take a 3.7 volt lithium ion battery with 2500 mAh capacity, if I connect it in parallel with another same battery, if I connect it in series with another same battery, I get around 7.2, 7.4 voltage of current. Yeah, if I connect two batteries in the series, I get 7.4 voltage of current, but the capacity of 2500 mAh remains the same. Now, next connection comes on parallel connection. This is the one more important connection when we need to increase the capacity of the battery or current, but keep the voltage same. Again, we take the same example of 3.7 volt lithium ion battery of 2500 mAh. So if I connect it to one more battery of the same, I get 3.7 volts. Unless like series, I get 3.7 volts of parallel connection. But here's the twist is, I get 5000 mAh of capacity. So these both are equally used in many sectors. For example, if I need more voltage, but if the capacity is same, it's okay for me. So I can go with series connection. If I need to power more devices or I need more voltage. Now, if I want more time, the capacity, more runtime on the battery, I can go with a parallel connection. So now you can ask how to do a series and a parallel connection of a battery. Okay. Now we'll come along a simple example. This is the plus of the battery. This is the minus of the battery. Now we'll connect 3 battery in series, 3 battery in parallel. Okay, now we got series. So what to do in series? We need to connect the positive to the negative, negative to the other positive of the battery. For example, this positive of the battery 1 to the negative of the battery 2, and the negative of the battery 2 to the positive of the battery 3. This is how series connection works. So here you get one wire. Now again what we do is, we do the same on the negative side of the first battery. Negative side of the battery to the positive side, and the positive side of the second battery to the negative side of the third battery. So now we get 2 wires. This is the positive and this is the negative. It gives around 7.4 voltage of current. So sorry, we have taken 3 batteries, so it will give 11.1 volt of current. Okay, but the capacity remains 2500 mAh. Okay, now what is series connection? Parallel connection. A parallel connection is nothing but very simple. Now we got the same 3 batteries of lithium ion 3.7 voltage. We make it like this. Then if we connect plus to plus, plus to plus, now we connect all pluses together and all negatives together. Now we get 2 ends. It gives 3.7 volt, but how much the capacity which it can give will be 7500 mAh. This is the difference between series and parallel connection. Okay, now we'll come across 2 9 volt batteries, how to connect them in series and parallel. Here I have taken a multimeter for reading the outputs. Now we connect the clip connectors to the batteries to get wire ends. Okay, now we got 2 ends. So first we go with the series connection. Series connection, we have to connect to a negative and a positive and the negative of another battery. So now we connect this. Again, we have to do the same on the other battery. Connect the negative of the battery 1 to the positive of the battery 2. Now here we have connected two 9-volt batteries in series. Now we will measure the output. We have to set multimeter to 20 volts DC, and now we will check the voltage. Now this is terminal 1 and this is terminal 2. As you can see here, we get 8.25 volts of current approximately. Now you can ask me why it is 9-volt battery connected paired seriously, why it has less current. So to prove that this battery at drained, so each one of them has approximately 4.5 volts. So that's why it's giving 8.30 volts approximately. So next time when you try you buy new batteries and check, definitely it will give you 18 volts of current. Okay, now we go with the parallel connection of the batteries. Okay, now we go with the parallel connection, which comes along like this. Okay, so parallel is nothing but positive to positive and negative to negative. So now we connect those together, and here we check it. Now the voltage remains the same. Since we cannot see the capacity in the multimeter, the capacity doubles like a two batteries, so it can run for longer period of time. Now we have got two ends, and now we connect it with the multimeter to read the voltages. So since the battery 2 has completely drained out, only one battery is working right now. So I just showed you the connections. Now we got the parallel connection around same 8.21 voltage. Since this battery is drained out. Okay. So yeah, I don't have any spare batteries to show you the connection, but these are the connections. This connection is nothing but positive to negative, negative to other positive for another battery. Same you have to do, connect the opposite terminals of each battery. Then in parallel connection is simple, but connect all the positives and all the negatives together to get to ends. You will get the increase in capacity. Okay. So today we learned about breadboard, how it is useful, and series and parallel connection, which is really useful for the electronics doing in connecting batteries. Yeah. So a small activity as usual for you is to connect a LED through a resistor with two LEDs with a resistor in series connection and parallel connection through resistor. Okay, so you have to observe that which one glows, which one has more brightness. Okay, this is your today's homework. And yeah, hope you like this class. Now we'll meet on day 3. Like, share and subscribe for more content. Bye.